Hello, our subject is probability and random variables and random signals. In this subject, we will study the probability theory, random variables and random signals related theory. In the beginning, we have to understand what is the difference between random system and random and deterministic system. Actually, random system and deterministic system is a classification made based on the results of this system. So if the result of the system is random, so we call it random system. But if it is deterministic, we call it deterministic system. It means not random. The random system is the system that gives results that cannot be expected by means of mathematical formula. So we cannot expect the result. We know the results only if we measure it. After measuring the results, we can know the exact result. So it is like measuring temperature or pressure, or when we measure the height of students, or when we measure the voltage in any phenomena that gives random voltage. These all results can be treated as random results. These results cannot be determined before getting the results by measuring. We cannot expect, we cannot express these results by means of mathematical formula. Now, for example, if we measure temperature and we get 30 Fahrenheit, 32 Fahrenheit, 40 Fahrenheit. If we get the results every period of time, it means every 2 minutes, for example, we get these results. But if we measure these results at the same time of the year, we can get different results. We cannot expect these results at all, only if we measure it. Now, these results, we put it in a set. These results, we put it in a set. This form is called set. Now, set is a collection of elements. It is a collection of elements. These elements in our subject is results, is result. These elements in our subject are results, or we can call it outcomes. Outcomes. So the set is denoted by capital letter, and the elements are denoted by small letter. A is the element. A is the element. It means if A is an element of A, we call it an element of A. If not, it is not an element. It is not an element of A. It's not an element of A. In a dice game, we say S equal to 1, 2, 3, 4, 5, 6. These are the results of the dice game. For the coin game, we say head and tail. These are the results. These are the results. Countable set. If its elements can be put in one-to-one correspondence with the natural numbers, which are the integers 1, 2, 3. For example, A equal to 1, 2, 3. Countable. 2, 4, 6. Countable. But if we have A equal to A more than 2 and less than 20, it is, by the way, continuous, and it is not countable. It is not countable. Finite element. The finite element, if we can count these elements, for example, A equal to 1, 2, 3. We can count these elements 1, 2, 3, or 2, 5, 6, 7. It is finite. But if A equal to 1, 2 to infinity, it is not counted. So we can say it is infinite. It is infinite. By the way, continuous also is infinite. A more than 1 and less than 2. It is also infinite. It is also infinite. Sample space S. Sample space or universal set is the set that contains all results. For the dice game, we have 1, 2, 3, 4, 5, 6. These all faces that can show up the all results. So we call it sample space or the universal set. For our coin game, S equal to tail and head. Tail and head. This is the sample space. Now, event set. Event set is a subset of elements. It is a subset of the sample space. It is part of the sample space of elements of some interest. For example, for the S equal to 1, 2, 3, we can say A is event of odd numbers, 1, 3, or even numbers, A equal to 2. It is event. Always event is subset of S. It is always subset of S. Null set. Null set is a empty set and denoted by phi. Denoted by phi. It is empty. Empty. Now, here we have very important note. 0, 0, it is not empty. We have an element which is 0. It is a result. It is a big result. We cannot treat it as empty. We have to know that doesn't mean empty. Phi. Null set is a subset of all sets. It is important to know. Now, if A equal to 1, 2, and B equal to 2, 3, 4. Now we have common element 2. But if we have A equal to 1, 2, and B equal to 3, 4, they are disjoint or mutually exclusive. It means they have no common result. They have no common elements. We call it disjoint. Disjoint or mutually exclusive. This is important concept we have to understand before going further in our subject. Please note that if A is an element of A, we write like this. If A it's not an element of A, we write like this. Now, one note about the type of the set. We have two types for writing a set: tabular form or rule form. Now, A equal 1, 2, and so on. This type is called tabular form. It is called tabular. But if we have like this, A odd numbers less than 10. Odd numbers less than 10. This type is called rule type because we have a rule here to determine the elements. We put or we write a rule here, not the element itself. We write rule about the element. This is called rule method. So we have rule method and we have tabular method. That's what's all about. Thank you very much and see you in another lecture.